Hello friends, welcome to sitza.com. Now in this video lecture we will discuss about the reaction mechanism. We all know that whenever we write down an organic reaction, we write down the reactants converting into the products. So whenever you write down any kind of a chemical reaction, any reaction there, you find the reactants converting into the products. But as we know that reactants do not directly convert into the products. So this is not something that occurs in one step. In the organic chemistry, most of the reactions do not occur in one step. Rather, what we find that these reactants, they first change into some intermediate compounds, and these intermediates then convert into the product. So these intermediates are very unstable species, unstable molecules which are formed during the reaction and also consumed during the reaction. Suppose we take here an example of an alcohol. Suppose we got the CH3 CH2OH. If we react with the hydrochloric acid, and what we find the hydroxide group is being replaced by the chlorine, and you get the CH3 single bond CH3 CH2Cl plus you get the water. This is the reactant here. These are the reactants, alcohol and the HCl, and the products are the ethyl chloride and the alcohol and the water. But what we actually find that this reaction doesn't occur in a one step. Rather, the reaction occurs in a number of steps. What happens first? In the acidic medium, the hydroxide group is lost as water. So hydroxide group is lost as water, this OH group. And what you get the CH3 single bond CH2 positive. This is an intermediate, carbon with a positive charge, which is called as a reaction intermediate. So this is a carbocation, and this is the first step that happens in this reaction. So first the carbocation is formed, and then in the second step, the chlorine, the Cl negative chloride ion, attacks on the positively charged carbocation and it forms the ethyl chloride. So this particular reaction occurs in two steps, right? This is the step number 1 and this is the step number 2. Writing down a reaction in a number of steps is called as the reaction mechanism, right? So to understand the reaction mechanism of any reaction, it's pretty important for us first of all to understand certain important concepts, like we need to understand the bond fission. What does the bond fission mean? What are nucleophiles and electrophiles? What are the different types of intermediates, right? Reaction intermediates and electron displacement methods in the covalent compounds. These are some of the important topics that we need to first understand, so that you can write down the mechanism of any reaction, so that we can understand the reaction mechanism of any reaction. So therefore, let's start first concept here, that is the bond fission. What does the bond fission mean? Bond fission is basically breaking a bond, right? So breaking down a bond, that is called as a bond fission. Suppose you have a carbon attached with the atom A. So breaking down of a bond here between the carbon and atom A is a bond fission. So bond breaking is bond fission, right? So how you can break it? There are two methods of breaking down a bond. Okay, there are two ways by which this bond breaking can take place. Number one is a homolytic bond fission. The second one is heterolytic bond fission. Okay, in homolytic bond fission, what happens? A homolytic bond fission, this is also called as the homolytic cleavage. Here, this is a symmetric bond fission. We know that a covalent bond which is formed by the sharing of electrons, and if suppose bond breaking occurs so that each atom takes one electron, so that suppose atom B takes electron, atom A takes electron. So now what you get, this is a free radical, this one is a free radical, right? This one is a free radical, this one is a free radical. So these are the free radicals that you get from the homolytic bond fission. In a homolytic bond fission, there occurs a symmetric bond fission, means each atom takes one electron. Okay, each atom takes one electron. And what are the species that we get? These are the free radicals that we normally get. So whenever a bond breaking occurs, suppose between the carbon and the atom X, so that carbon with one electron, atom X with one electron. So these are the free radicals, right? These are highly unstable species. These are also very reactive species called as free radicals, right? So radicals are neutral and are odd electron species. These are the neutral molecules but odd electron species, and they are also electron deficient, right? So suppose carbon with one electron here, total number of electrons in the carbon will be now 7. So it's also a electron deficient. So free radicals are also electron deficient. So when a homolytic bond fission occurs, you get free radicals. A homolytic bond fission is favored in non-polar nature of the bonds, right? And when you use high energy radiations. Homolytic bond fission can also occur when we use some peroxides, right? Now what about the heterolytic bond fission? In a heterolytic bond fission or heterolytic cleavage, the electron pair that is being shared by the two atoms, right? Normally a covalent bond is formed by the sharing of electrons. Atom A provides one electron, atom B provides one electron, so they form a covalent bond. But now when the bond breaking occurs so that both electrons, they go with one of the atom, either suppose they go with the atom B or they go with the atom A. Atom A is lost here with the electron pair, so that atom B here is lost with the electron pair, so that the atom B gets a negative charge and A gets a positive charge, right? So what are these? These are the charged species that we get, and they are called as ions. So these are the ions, right? The charged species that we get here, these are the ions. Ions are of two types, cations and anions. A species with the positive charge is called as a cation, and the species with the negative charge is called anion. Okay, so ions are of two types, cations and anions. Okay, cations and anions. Anion is the one with the negative charge, cation is the one with the positive charge. Atom A can also take electrons, and in that case atom A will be the anion and atom B will be with the positive charge, so it will be the cation. Whether electrons go with the atom B or they will go with the atom A means whether this type of a heterolytic bond fission will occur or this type of heterolytic bond fission will occur. It depends on the electronegativity of the two atoms, right? Suppose if the atom B is more electronegative atom, then electrons will go with the atom B. If A is more electronegative atom, then electrons will go with the atom A, so A will be the anion in that case. Heterolytic bond fission occurs in polar bonds. Okay, so if you have a polar bond, normally it undergoes a heterolytic bond fission, and polar solvents also favor the heterolytic bond fission. Hope you got the concept. Thanks for watching the video. Bye for now.